Hello everyone, my name is Laurent. I'm working in the IPDX team at Protocol Lab. I'll be honest, this is the first time I'm doing this talk, and it kind of feels like testing in production, which is your worst nightmare when you work on testing, right? So bear with me. For the past few months, I've been working closely with the libp2p team. We created the tool and tests that are used to verify the compatibility of Go and Rust libp2p. So what do we mean with, by interoperability testing, and why do we care about it? There are many implementations of the libp2p specs. There is a JavaScript implementation, Rust version, a Go implementation, a NIM implementation too, right? Java and more. With each of these implementations comes many released versions too. So the goal of interoperability testing is to make sure every implementation and every version can communicate with each other. Obviously, it's important to us for multiple reasons. libp2p is designed to support large decentralized peer-to-peer networks, so the more implementation can talk to each other, the happier we are, right? We also rely on interoperability to provide cool features like hole punching. And we have to assume users won't upgrade their versions. They should, but they don't always upgrade. So we have to be very careful about backward compatibility. And when you think about it, backward compatibility is interoperability with older versions. So libp2p interoperability is important to us. And this is why we created this test and these tools. Let me share the outcome first. So we all know what we are looking at. This is what interoperability would look like. The matrix on the left is a simplified version of what we're working towards. You take every Go libp2p version, every Rust libp2p version, you run some magic, and it tells you which version can work together. If there is a red dot somewhere, it means two versions couldn't talk with each other, and I have an interoperability issue, which might be a missing protocol, or that there is a bug somewhere. So everything is green, we're happy for now. Keep in mind, this is a simplified version. We'll have many more parameters, like the type of protocol, the transport, the mixer, etc. We expect this matrix to become huge, so our constraints are also maintainability and scalability. And another important feature to us is the ability to run in CI. So that's the screenshot on the right. And yeah, that's our two goals. And to create this test, we use a tool called Testground. So Testground is a platform for testing, benchmarking, and simulating a distributed system. It's designed to be scalable. We used it in the past to simulate thousands of nodes. And it's also designed to be language agnostic and runtime agnostic, which is exactly what we need here. Protocol Lab used Testground before. We used it to work on IPFS DHT improvement, Filecoin improvement, and libp2p optimization. Other teams are using Testground right now. Sigma Prime is using it to test improvement on the Ethereum network. And there is also Magmo that is using Testground to measure performances for their project. Alex from the Magmo team shared a great presentation about his work on Testground. That was during the Retrieval Summit. The video is not online yet, but I recommend you check it out when it is. So let me try to share enough detail about Testground to convince you it's clever and that you want to take a look at it. Testground lets you define a plan for a small or large network of instances. It provides network simulation and network isolation features. It gives you tooling to define a plan, build it, run it, then gather results and metrics. It's well designed. Once Testground created the network and started the instances, it pretty much disappears. There is no global orchestrator, so it's really designed to minimize the noise in your test results, which is a very, very clever design. And what we did here is we created a new use case for Testground with the interoperability work. Conceptually, it's easy to write a distributed test for Testground. You just write a scenario from the point of view of the node, and Testground takes care of building the code, setting up fancy isolated network, and do all the runtime and stuff. So that's what the libp2p ping test looks like right now. It's very basic. As a single node in a network, I start a libp2p instance. We're using Docker, so every instance gets their own isolated network interface. Then, still as one node in the network, I send my IP and my libp2p ports to other instances in the network. Everyone does the same, and we all learn about each other's addresses via Testground synchronization service. When we are done with the synchronization, I, as a node, dial into other nodes, and I send a ping n times. If the connection and ping is complete, I record a success, else I'll record a failure. So that's it. This definition is implementation agnostic. We have a version implemented in Go, which is really just a main.go file, and we have another one that is implemented in Rust. We're working on a JavaScript version. Anyone can fork the repo right now and add their own ping test implementation. So NIM, for example, could fork this, add their own ping test implementation. It's relatively easy to test new libp2p implementation, and I'll share a link and references at the end. Okay, so now we have a test definition and a few implementation. How do we use this with Testground? We take our code, the main.go, for example, and turn it into something that Testground can run, can build and run. In our case, it's enough to be able to create a Docker image. We also spend some time making sure we can parameterize the build to use different libp2p versions. Because remember, testing one libp2p implementation is great, but it's not enough. We also want to test many libp2p implementation. And we want this testing to be maintainable. So in the case of Go, we're using shims, build tags, and custom mod file for every version. You can see this on the image on the right. In the case of Rust, we're using feature flags and some rewrite in the cargo.toml at build time. It's not easy to implement all of this, but it's simple. Once my container can be parameterized with this version, it's flexible enough to join the whole interop test suite. So the next step is loading this code into Testground, and for this we use a file called a composition file. So a composition file is our test configuration. We use it to configure build parameters and runtime parameters, like number of instances, version combination, etc. In this file, we list a bunch of test groups. Each group is like a template for one or more test instances. For example, this is the code we use to describe the Rust instances. Testground composition supports a simple templating language. So if you look at the top, we load a file, load resource rust.toml. So we load this resource file and iterate on it to generate many groups dynamically. So we have all this templating stuff that we use to enhance our composition file, which makes the interoperability testing slightly more complicated, but it's also it's a useful scripting language, right? In the end, as a libp2p maintainer, you can just edit the resource file, so the rust.toml at the top, and you never have to look at the build template if you don't have to. So I got my test plan, the composition file, and to execute it, I'm just going to call Testground Run over this composition file. This is it. You call Testground Run, it loads the composition file and builds the Docker image for every groups defined in the composition. So you can see the Docker build lines over there. So that's one container. This is more Docker build, so that one is a Go instance. More build, this is Rust, you can see here. And then that's it. We built all the Docker images. The test starts. Testground sets up the network and start the containers themselves. The instance synchronize with each other's. So you can see here there's a different version. Some of them are Rust, others are Go. They're done synchronizing, and now they connect with each other's, and they ping each other. And they go through this process a couple of times. And at the end, you can ignore the error message at the top, because at the end, we can see, OK, all the instances are happy. So every version return OK, and where everybody could talk to each other, right? And you can see the outcome, which is well hidden, but there's a outcome equals success. Outcome equals success at the bottom. So that means all my instances with 12 different versions of Rust and Go libp2p could talk to each other and ping each other successfully. So we got it. Thanks to templating, we also have different flavors for this test. So we have the Go cross version, which will test every known Go version, plus a custom branch. We use this to test pull requests in the Go libp2p repo. There's the same one for Rust. We have a cross implementation latest, which runs Go latest and Rust latest, plus a custom branch, and we use it during pull request too, so we're testing this. And finally, there is a cross implementation all test that starts a network with every known version, which is dozen right now. It's not used in CI for now. So remember, that's our goal, and we got it. We'll share the matrix later. And that's not all. We caught a bug. We caught a bug already. So I'm excited, because that's the result of a lot of work. We created a new use case for Testground. We implemented many Testground improvements, especially stability improvement. We explored how to write interop testing and how to build a maintainable test suite with dozens of versions. And we got a bug after a few weeks after the release. So this is a massive positive feedback for us. And it's great because we caught it before it had a chance to get released, right? And this is only step one. So let me just share a bunch, some info about the next steps. We have a huge list of things we want to work on. We are going to release new Testground features, which we'll use to simplify debugging and support much more complex test suites. If you used Testground before, and you're still traumatized by the experience of setting it up, installing it, and the lack of documentation, just come and let's have a chat. The interop work we did in the IPDX team showed that Testground has a tremendous potential, and we want to unleash this potential, right? So let's talk, because we want to improve Testground, and we want to make it more approachable. On the libp2p side, we are going to add more tests and share interop matrices. We are also working with Little Beer Lab, on Node.js and browser support. So this is coming soon, thanks to Glenn from the team. It's a good time to get involved, because we basically went from nothing to one test, or some test. And now we're planning the switch from some tests to many tests, which is the easy part, right? We all know that. Finally, if you are working how to get involved, if you are working on libp2p or you are using it, come and take a look at the libp2p test plan repo. You can even fork the repo and add tests for your own implementation. Same thing, let's have a chat if you want to do it, because if you want to add your implementation, because we're happy to help. And finally, the best way to get involved, and I'm slightly biased here, is to join the IPDX team. We all solve these kind of shared problems, and Testground is a big part of our work at the moment, sorry. So the QR code on the right links to a page with all the URLs for the talks. And yeah, get more info there, and let's have a chat if you have any question. Thank you very much. Yeah. Is there any questions?
Can you also catch regression issues, let's say, or to, let's say, design test plans so that a given implementation doesn't cross a given CPU threshold or things like this?
Oh, yeah. So that will be like performance metrics and measurements. So that's something Testground can do, and I think the team wants to do it. I haven't used it yet, so I cannot talk much about it. But Alex is using it for Testground for performance measurements on Magmo, so you should definitely ask him too. Yeah.
So what's the, I think it's called testing cadence, so do you want to test only the release candidates, or do you want to have it running on every PR that gets merged? Maybe just that.
That's a very good question. Yeah, that is a very, very good question. So we want to do both. We know that some testing will take some time, and we When you have a test suite that takes 40 minutes, for example, to build and run, that's something you want to test on every release and not on every PR. So we're still like trying to figure out all the parameters, but basically we assume we want to be able to run some tests on every PR. And so that's what we do with 2 small tests we have, Go versions and latest versions. But we also know that we'll have probably larger test suites, like the cross all version that test every known versions that we run only before a release. So yes, we want both, basically.
Great talk, thank you. Do you have any plans to use metrics that are produced from Thunderdome into Testground?
I'd love to. We even had a chat with the ProbLab team. So I'd love to set this up. We don't know how we can use this yet, but we know like eventually we want to use this, right? Because Testground is great at setting up synthetic networks and doing like conformance testing. But when it comes to when you reach like performance discussion, right? You want to set up actual realistic networks. And so, yeah, we think that Thunderdome and ProbLab's work could be integrated into Testground. And if you have an idea on how to do it now, just let's have a chat.